I welcome you for this video lecture. Today, I have planned to explain the procedure for testing means under small sample category. So already you know there are mainly two types of test of significance are there. One is called test of significance for attributes, another one is called test of significance for variables. So now we are going for test of significance for variables. So already I was given you the meaning for attribute and variable earlier. So now directly we are going for test of significance for variables. So especially under variables there are mainly two types of testing problems are there. One is called a large sample test and another one is called a small sample test. So already you know if the sample size n is less than 30, then we can call or we can use small sample test. There are several tests there under small sample test. So I am going to explain detailedly one by one. The first test is test of significance for single mean when population variance unknown. So this is the first test, test number 1. So what we are going to do based on this test means we are going to test the single mean when the population variance are unknown. For example, one population is there, one single population. From that population, suppose if you are selecting a sample, the sample size is like for example 10. The 10 means here we have the sample size 10, that means this is less than 30. So this comes under small sample test. And also this instead of the mean and population variance, so we may be given the sample observations means based on this sample size and sample observation. So we are going to, if you want to test the population mean whether it is particular value or not, means in that situation we can go for test for single mean. Only single population, from it single sample must should be selected. Then sample observation we can have. Then if you are having this type of situation, then we can apply test for single mean. Test of significance for single mean when population variance unknown. So you know only the mean. So if the population variance are unknown means we can use this. And especially already you know there are 5 step-by-step procedure is there for solving any problem. So as per our procedure, first we suppose to set up the null and alternative hypothesis. So here the null hypothesis for testing the single mean when the population variance of unknown means, then mu is equal to mu naught or x bar is equal to mu. So in this situation mu is equal to mu naught is nothing, but if they are asked us to check whether the population mean mu will be a particular value or not, means then we are going to use mu is equal to mu naught. X bar is equal to mu is nothing, but here we are going for another hypothesis, x bar is equal to mu also. When we are going to apply this x bar is equal to mu means if the question will be is there any significant difference between the population mean and sample mean, means we can go for x bar is equal to mu. So this is a test statistic which we are going to use to test the single mean when population variance are unknown. This is a formula. If the sample size is small means then it comes under t test. Therefore you see x bar minus mu divided by square root of s square by n minus 1 followed by t distribution with the n minus 1 degrees of freedom. So already I has informed you, if the sample size is small means then we should go for the testing procedure should converted into t distribution. That's why we are using t distribution for testing the single mean here. And you see here already you know the same formula for x bar is equal to summation x by n, small s square, the sample variance equal to summation x square by n minus summation x by n the whole square. So this is the very simple formula to test the difference between the population mean or sample mean, or to test if the population mean or sample mean to test if the population mean can be a given value. In that situation we can use this formula. So after applying the formula, then when we are rejecting the hypothesis means if mod t greater than t alpha means we are rejecting the hypothesis. We are rejecting our hypothesis. So this is about test for single mean. So similarly we are going for test for difference of two means. This is the second test which we are going to study under small sample category. Test 2, test of significance for the difference between two means when population variance unknown. The same category the same procedure we are going to apply for this type of test also, difference of mean. So only slight difference between single mean and difference mean. When we are talking about single mean, here, so we have used only a single population and we have selected only single sample from it. But when we are talking about difference of mean, here we should go for this particular problem for difference of two samples, that like N1, N2, that N1 and N2 are selected from two different populations. Suppose if you are interested to test, is there any significant difference between the means of that population? So in that situation, you can apply mu1 is equal to mu2. Is there any significant difference between the means for the sample mean? In this situation, you can use this hypothesis, especially x1 bar is equal to x2 bar. So that the main difference between the single mean and difference of means here we have used only single population and single sample. Here we have used a difference of, there are two different populations, there are two different mean samples, we also should select from that. So this is the test statistics which we are going to use to test the difference of two means. Modulus of t is equal to x1 bar minus x2 bar divided by s square into 1 by n2 plus 1 by n1 plus 1 by n1 plus 1 by n2. So this is the test statistics. So this test statistics again followed by t distribution with the n1 plus n2 minus 2 degrees of freedom. Already has given you the meaning for degrees of freedom. So df is nothing but it's a symbolical, we can denote the degrees of freedom into df. Already has given you the meaning for degrees of freedom. Degrees of freedom is nothing but number of independent values that vary from the sample size. And as usual, formula for calculating x1 bar is equal to summation x1 by n1, x2 bar is equal to summation x2 by n2. So this is the formula for first sample variance, second sample variance. After calculating all these things, there will be a separate formula for calculating the capital S square. Capital S square is nothing but capital S square is equal to n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. So this is the formula for calculating this capital S square using the sample variance. So easily we can calculate capital S square. Then after calculating the mod t, then we are supposed to check our mod t to our table value. So when we are rejecting our h0 means reject h0 mod t greater than t alpha. T alpha is nothing but the table value of t distribution with the alpha level of percentage of level of significance. So this is about the formula and procedure for testing single mean and difference of mean. So we will see the problem in the next video. Thank you.